Thank you so much, Lisa. That was a beautiful introduction. I hardly recognize myself. It is such a thrill for me to be with you here in Australia at Esri. I've been reading about Esri for years, and so I'm finally here. And given that we are in one of the great coastal cities of the world, I did want to take a few minutes before your lunchtime to tell you a bit about the oceans, particularly in terms of swells, soundings, and sustainability, and how our science, the science of where, plays such a critical role in this. So if we can start with the first video, we'll take a look at what I mean by swells. So this is a visualization of how truly dynamic our oceans are. It's a visualization that was created from a global circulation model that draws from satellite data as well as sensors that are actually in the oceans. So as we zoom into Australia here, you can see how the oceans are literally the lungs of our planet, living, breathing. And did you know that over half of the oxygen that we breathe comes from the surface of the ocean? It comes from air-sea interactions. It comes from the oxygen produced by the tiny plants that are known as phytoplankton. So the oceans are absolutely critical to our life on this planet, regardless of where we live. And if we stop at this point in the middle of the Pacific, we can see that our planet is literally a blue planet. It gives us another view of how much we really rely on the oceans. Now, if we go to the second video and go from swells to soundings, if we drain all of the water in the oceans off, and we can see what the topography of the seabed is, or the ocean floor is, we get yet another view of the complexity and the dynamism of our planet. So we see that we have the deepest trenches, some of the highest mountains that are on the seafloor. And did you know that your internet and phone traffic lies in these depths? Your ability to get your Twitter feeds or your emails, it's dependent on the submarine cables that are on the ocean floor. So this is one of the many reasons why it's so important for us to have a really accurate map of the global seabed. And we are so far away from that. We're only 15% of the way there. There is an initiative known as the Seabed 2030 Initiative that is trying to rectify this and to give us a seamless global map of the world ocean floor, of the seabed by 2030, so that we truly have a full understanding of this planet, so that we truly have maps of the seabed that are as accurate and as detailed as many of the maps that we have on land. This is an increasingly important initiative, particularly with climate change, with the UN Sustainable Development Goals. And it's so wonderful that Geoscience Australia is one of the leading lights of this effort. So speaking of sustainability, I hope that we are all very familiar with this wonderful infographic now. The idea that we are really going to try now, not just the developed nations, but all of the nations of the world, are going to try to solve some very vexing global problems by 2030. 2030 is going to be a big year in terms of reducing or getting rid of poverty, making sure that women are educated, gender equality, making sure that people have clean water. There's 17 of these goals, and this is the United Nations Sustainable Development Goals for 2030. Many of us are focused on a couple of these goals, one of them being Goal 13 for climate action, not just for climate understanding, but for climate action. And we as Australians, as Americans, as citizens of the world are increasingly convinced that we must act now. But since I'm talking about the oceans today, I'm going to focus on SDG, Sustainable Development Goal 14, which is about life underwater. And this is focused on reducing as much as possible the pollution that is in the ocean, the marine debris, the plastic waste, making sure that we stop the overfishing of the oceans, which is going to be extremely detrimental not only to the oceans, but to us. Solving problems such as the acidification of the ocean because of the greenhouse gases that are in the atmosphere. The oceans are helping us out by absorbing that, and as they are taking that on and absorbing it, they are becoming more acidic. We also, as much as we depend on the oceans for the oxygen that we breathe, we are now faced with the deoxygenation of the ocean, the reduction of oxygen. So time is running out for some very, very critical issues. And geospatial, the work that all of you do with GIS, with data science and so forth, is very, very important in this. And we have to get across the idea to our colleagues and friends, to our decision makers, that mapping the ocean is more than this. This is extremely important. This is a nautical chart. Many of us think of a map of the ocean as a nautical chart for navigation and shipping. This is extremely important, and we have electronic nautical charts that we support in ArcGIS, but we're doing so much more now. For instance, at Esri, we've been working for the last couple of years on a project known as the Ecological Marine Units, and we're extending this to the Ecological Coastal Units. The Ecological Marine Units takes 52 million observations of temperature, salinity, dissolved oxygen, and the three major nutrients of the ocean. This is the foundation for life in the ocean. And it uses spatial statistical clustering to create several zones of these units, ecological marine units. And we've now come up with ways of cartographically representing this in 2.5 dimensions. We're moving towards true 3-dimensional realization of this, but right now it's 2.5 dimensions. And it's also a free and open data set. There is an app. Of course there's an app for your phone or for your tablet so that you can explore, you can drill down into the ocean. This is a full digital ocean from the surface down to 5,000 meters. And what we're working on now in this phase are use cases of the ecological marine units where particularly ecologists are finally attaching the biology to those volumetric regions in the water. So we have use cases around the world. These are, I believe, just 6 of these. We welcome use cases from Australia. So I've been talking with my colleagues about participating in that effort. Now, as we know, particularly after GIS Day last week, that we are talking about some very advanced technology now. GIS is not just a map on your wall or in your glove box. We are talking about smarter maps, like smarter government, spatially intelligent, superpowered with analytics behind it. You know, this is what we've always known about GIS, but what we are communicating now, particularly to policymakers, to decision makers. And as we know with the ArcGIS platform, we have the spatial analysis and data science that has been supercharged with open science libraries. We're working with Jupyter Python notebooks. We're using the ArcGIS API for Python, their analytical servers. We have all kinds of interactive computing that is a force multiplier for the science that we do in the oceans, for the science that we do on land, for just about everything. So this is a really, really exciting time to be in GIS. We are taking legendary maps, such as this seminal map of the world ocean floor that was created in 1977 by one of the true legends of ocean or marine cartography, Marie Tharp. She actually invented the field of marine cartography, and she was kept from publishing about this. She was kept from going to sea until later on in her career, but now her story is being told far and wide. And our ocean base map team, in collaboration with colleagues all over the world, including the General Bathymetric Chart of the Oceans that Geoscience Australia participates in, we are taking the equivalent of the Heezen and Tharp World Ocean Panorama and is now interactive, of course, as a base map, as a web service. So we've got bathymetry in the cloud. And we can overlay, of course, all kinds of wonderful data on our base maps. The simple dots here are just the places that I've been at sea during my years. We can also overlay many, many types of other interesting data, such as this animation that was done by the University of Hawaii at Manoa. And what it's showing you is the 1.5 million tons of marine debris that were set loose across the Pacific after the March 2011 earthquake and tsunami in Japan. This was an amazing event for many reasons, but for those of us who live on the West Coast, we were affected by an event that took place all the way on the other side of the Pacific because of all this debris that kept coming across the Pacific in the dynamism of the circulation, as you saw in the earlier video. Even whole docks that broke off from Japan and traveled all the way across the Pacific to Oregon. So this has been an ongoing problem for many, many years, mainly in Oregon and California, some parts of Washington, where we have still been receiving the debris from the 2011 event. So this was the latest thing that washed up on the Oregon coast as late as 2016. But we can take these types of animations, show spatially what is going on, and continue to work toward solutions. There are also wonderful innovations in cartography in terms of how we're communicating this science, how we're communicating, in this case, how dangerous the ocean is. This is from the fateful 2005 year of tropical storms and cyclones that raged throughout, or typhoons that raged throughout the Pacific Ocean, just to the north of us. And in this type of visualization, we're looking at the hurricane or the typhoon tracks, but also the intensity of the typhoons in terms of the barometric pressure expressed as columns. So this is very, very communicative. It's part of the Maps We Love collection that's on the Esri website, showing us not only the horizontal track of these typhoons, but also the vertical column expression of how intense these storms got along the specific track. Cartography is a wonderful thing to have for so many different applications, and we are very, very excited about this new projected coordinate system that's going to be available in ArcGIS Pro 2.5 and ArcMap Desktop 8.0. This is the famous Spielhaus map that shows the ocean in a completely different light. It shows the ocean as one body. And certainly with all of the crisis that we are experiencing in the ocean, this might be one way to communicate to all of us how critical it is that we all work together. It's one ocean. It's not just the Pacific versus the Atlantic versus the Indian Ocean. So Athelstan Spielhaus was an amazing meteorologist, oceanographer, and inventor, and he created this map in 1942. And he specifically put Antarctica and Australia in the center of this map. It's about time. It's about time to see Australia at the center of a map. I really like this map for that reason, especially with Australia's participation with their large Antarctic research stations as well. You have this Antarctic territory that you have been monitoring for many, many years. But what Spielhaus wanted to do was to indeed give the world the idea that we are one in terms of one ocean. The problem is that he did not do the mathematics to actually put this into a projection. But our projection geometry team at Esri was so excited about this, and we heard from a customer in Europe who wanted this map in ArcGIS Pro, that they did the mathematics to take Spielhaus's idea from 1942. They used the Adams square 2 projection to create a Spielhaus projected coordinate system that will be available. So you can use this map. You will be able to use this map for all kinds of different purposes. The cartographers are having a wonderful time now because this is the Spielhaus map with the global seafloor geomorphology originally from Geoscience Australia, rendered in this projected coordinate system. So you can see the global mid-ocean ridge system of volcanoes and earthquakes. You can see all of the major faults and so on. This seafloor geomorphology layer is in the Living Atlas of the World, and it continues to be maintained by Grid Arendal in Norway because Dr. Peter Harris moved from Australia to Norway. Now, given all of these wonders, given all these advances, there be monsters. We still have many challenges. There's still many things that are vexing to us, even with the technology that we have. One of these is the achieving the vision of openness. So we've just heard from Gary about that in terms of open data in government. Open data in science is still incredibly difficult. We are talking about it in the scientific community all the time now, which is a very good advance, especially in terms of open data, but open services for those data. And what is sweeping throughout the scientific community right now is a discussion of FAIR data, where FAIR stands for findable, accessible, interoperable, and reusable. And this is not only for our publications and our research data and materials, our apps, our source code, but making this access available to policymakers, to, of course, other scientists, to industry, to school children, to everyone, to reinforce or reassert science as a global public good, especially as science is under so much attack these days. And so the ArcGIS platform is very important for this, with our system of record, our system of engagement, our system of insight, and the federation of these systems. Now, we also have challenges in terms of the 3 V's, volume, velocity, and variety. In terms of volume, even in the oceans, as much as we still need to explore, we are actually challenged in the near shore with some of our bathymetric mapping systems. We have too many soundings sometimes. So a typical bathymetric sounding system can collect about 115 gigabytes of data per hour. And a fun analogy is that if you take that to a 1.5 billion to 1 ratio, if you have a marble that represents the Earth, and you're collecting data at that rate, this marble will quickly become the size of the Earth itself. So that is a lot of data. That's big data. We also, you're supposed to laugh at that, but okay. The other flip side of this is we have dark data. The data that we do have for parts of the ocean, particularly the deep ocean, sometimes it's not updated properly to nautical charts, and so we have terrible tragedies resulting, such as this incident that happened in 2005, where a nuclear submarine literally ran into an uncharted underwater volcano, an uncharted geo. And 1 sailor died, 115 sailors were injured. We know about the MH370 tragedy. We still have not found that plane. There's been a lot of surveys to try to find the wreckage. Geoscience Australia, again, has been at the forefront of that. And one of the nice twists to this story is that all of the data from the surveys have been released to the scientific community, to the point now where we have parts of the Indian Ocean that are mapped in such nice detail, and this is the work of Kim Picard and her colleagues from Geoscience Australia, that we have better, wonderful maps to help us understand the tectonics, the geophysics, the geomorphology of the Indian Ocean. In terms of velocity, we can now stream 30,000 GIS features per second. So what does that mean in terms of stream reasoning, in terms of storage? In terms of variety, we have the delicious problem of so many different types of formats, data sets that come from different sensors in the ocean. Despite the paucity of data we are trying, we have about 2 million sensors in the ocean. That's projected to double every 5 years. And so the problem of dealing with the variety of data coming from the variety of sensors is also challenging. A fourth V, though, that I'd like to put forward is values, in terms of the value that we ascribe to what we have collected, but also making sure it's open and available and usable by communities, making sure that we are listening to the traditional indigenous knowledge, the First Nations who are part of this community as well. So this returns me to the Sustainable Development Goals. And given how wonderful these goals are, and there's 17 of them, what are we doing to make sure that we can monitor and track the progress towards actually achieving these goals? So it is wonderful that the United Nations, working with Esri, now has a hub site, an open data hub site on the Sustainable Development Goals, which you can get to at the address there. And we should all be aware of the UN Decade of Ocean Science for Sustainable Development. It's a decade of science, but it's a decade of science for sustainable development to make sure that science is used toward achieving these goals so that we have a safe ocean, sustainably harvested and productive ocean, transparent and accessible in terms of the data, clean, healthy, resilient, and predicted. And it's wonderful that the chief scientist of Australia's Bureau of Meteorology, Sue Barrell, is one of the leading lights of this effort. So we are in another exciting age. We hope that there will be a groundswell or a sea swell of awareness of all of these issues regarding the ocean, regarding our planet as a whole. In terms of soundings, we need to communicate, sound out these issues with our leaders, with our families and friends, with our universities and so forth. Sustainability, of course, is what we're all after, and we have reason for hope. So thank you so very much. Really hope you enjoy the rest of Esri, and thank you again.